4.1a will not be directly on the test. 4.1b, let's look at converting radians to degrees or degrees to radians. And I want to start with the second one first. So give the exact value in terms of pi by converting 330 degrees to radians. So remember, if you're not sure how to do this, the easiest way to do it is to set up a proportion. So they've given us degrees, and we want to set it equal to radians. So a full circle, we know, has 360 degrees and 2 pi radians. So that's what goes on the bottom of the fraction. And now they've given us 334 degrees, so that goes here. We need to find the radians, so that's our unknown. Now, the first thing I would do is try to simplify this side. It'll just make things easier for you. So to simplify, we can cross off the zeros. And then if you look at this, I can actually divide 33 by 3 and 36 by 3 and get 11/12. So let's rewrite this as 11/12 is equal to x over 2 pi. Now to solve this equation, all I have to do to get x divided by 2 pi is to multiply by 2 pi on both sides. And when you do that, the 2 pi's cancel out here. What we could actually do is simplify again. We can take the 2 and the 12. So I'm going to do 2 divided by 2 is 1. 12 divided by 2 is going to be 6. So when you multiply straight across on here, what we're going to get is it's 11 pi over 6 is the answer. And you would have to show the work for that. Now, if you do want a shortcut trick for this, the one trick I will use is that I know I need to convert degrees to radians. So what I will do is say, you want pieces of pi. I know that there's 180 degrees in a pi. So basically pi and 180 written as a fraction like this are equivalent. And then all you do is you take the 330 and you put it up in here. So if you do that, you're going to have the 330. Again, you would just simplify accordingly, which those would cross out. And when you simplify this, you can pull a 3 out of everything. And what will happen is this will still become 11 pi over 6. So you're more than welcome to use that trick, but you must show some work. Now let's look at this one. How many degrees equals 3/2 radians? Now be careful, this 3/2 radians is not in terms of pi. This is actually in terms of just the radian part, which means how many times you can lay the radius out on this circle. So 1.5 times you can lay the radius out is what that means. They want to know how many degrees that is. So if you sketch it, that's 1 radian, a half a radian is maybe that. So how many degrees is that? Easiest way to do this is just set up a proportion. We want to go from degrees into radians and vice versa. So 360 for a circle. The radians would be 2 pi's. I don't know the degrees, but I know that this is 3/2. Now what you need to do is, here we have a complex fraction, which is a fraction and a fraction. Let's get rid of the denominator. The 2 pi is the same as 2 pi over 1. To clear that out, all you would do is multiply by its reciprocal, which is 1 over 2 pi, or 1 over 2 pi. When you do that, what you're going to get is we're going to have the x over 360 is equal to, over here we're going to multiply straight across, 3 divided by 4 pi. Now what I need to do is get x by itself here. This is x divided by 360, so all I need to do is come in and multiply both sides by 360. So I'll do 360 there and 360 here. Those will cancel out, and then we're just going to be left with x is going to be equal to, and I'm going to simplify the 4, and I know 360, I can do 4 divided by 4 is 1. 360 divided by 4 would be 90, so let's cancel that out. Let's make that a 90. Straight across, 3 times 90 is 270. Be careful, there's still a pi and it's on the bottom. And that's actually the answer as a degree. It's an odd looking answer, but it is 270 over pi degrees. Now let's go to 4.1c, convert radians to revolutions or revolutions to radians. Here we have negative 5/8 of a revolution, and they want to know how many radians that is. If we were to sketch that out, by the way, here's what it would look like. Your negative here means you have to go backwards, and 5/8 is about 0.625, so you're going to go negative 62.5% of a circle, so 50% and a little bit more. So we want to know how many pieces of pi that is. Remember, a half of a circle is 1 pi, so this is 1 and a little bit more. Again, the easiest way to do this, if you're not sure, is just to set up a proportion. So I want to know revolutions, which is 1, and I want to know the radians, which is 2 pi. Revolutions we know is negative 5/8, but we don't know the radians. So really this right here, negative 5/8 divided by 1, is just negative 5/8. So all we have to do is solve for x, which is x divided by 2 pi. So to clean that out, we're going to multiply both sides by 2 pi. Do 2 pi over here. So that's then going to look like x equals, it'll be 2 pi times negative 5/8. And if you multiply straight across, we're going to get negative 10 pi over 8. Now we do have to simplify this fraction. I'm going to take a 2 out of both of these. So it's going to be negative 5/4 pi. Now the trick to doing this one is just knowing that a full circle in terms of revolutions is 2 pi's. So what I could have done as a shortcut is I said a full revolution is 2 pi's in terms of radians, and they just want negative 5/8 of that. If you do this and simplify, you're going to get the same answer. So what you would want to do at a minimum is at least show this work. 4.1d, convert from degrees to revolutions and revolutions to degrees. So here we have 1300 degrees, and they want to know how many revolutions that is. Again, if you weren't sure what to do, your proportion would just be degrees for a full circle, which is 360, is equal to 1 revolution. I don't know revolutions, but I do know the degrees. When you simplify this, we could either keep it as a fraction, or we can go into a decimal for this one to better understand the revolutions. So let's just divide these two numbers in the calculator and get the revolution. And that's going to come back and give us a revolutions of 3.61 times around a circle. Now the shortcut for this one is very much like it looks like as a proportion. All I do is I know that there's 1300 degrees, and one circle is 360, so I would divide it. If you solve this, you're going to get the same answer. 4.1e, state multiple magnitudes of rotations. So here, sketch the rotation of 7 pi over 6, and then state its next positive and then negative rotations. So this is an improper fraction, which is how we state radians. Sometimes it's easier to read it as a mixed. So 6 goes into 7 evenly once with a remainder of 1. So it means do 1 and 1/6 of a pi. We always start right here. Remember, half a circle is 1. So I know I need to do a 1/6 of this. So if it helps you, you can partition this to visually see it in 6 pieces. We want 1/6 of that, so this is where we're going to land. So this is 7 pi over 6. Now they want to know the next positive, and then they also want to know a negative rotation. If we do the negative rotation, that's just going to be coming in backwards this way. So if you look at the partitions I've made, you can tell that we're doing 5/6 of this and it's backwards. Now mathematically, how you can get that, what you can do is you can actually take 7 pi over 6, and you're going to subtract from it 2 pi's. Let me show you where negative 5/6 of a pi comes from. You can just make this over 1, get a common denominator by multiplying by 6 and by 6. So what we're going to do is 7 pi minus 12 pi, which is going to equal the negative pi over 6, which we can nicely see in the actual graph here. Now the next one is they want the next positive rotation. So on here, the next positive rotation would be, I would do a complete 2 pi of a circle and then add to it the 7 pi over 6. So what I'm doing here is 7 pi over 6 plus 2 pi's. And we do want to keep it as an improper fraction, so put it over 1, multiply by 6 to get a common denominator. And this would just be 7 pi plus 12 pi, which will give us 19 pi over 6 as our answer. The key to this problem is you can continually add pieces of 2 pi's or subtract pieces of 2 pi's to get various answers. 4.1f wants us to compute arc length of a circle using the degrees or the radians. Now here it says find the arc length of moving 60 degrees around a circle with a diameter of 10 feet. Here's what this sketch would look like. So what we have here is, be careful, a circle with a radius of 5 feet, not the diameter of 10. I moved 60 degrees right here in the red, and I want to know the green arc length. There's 2 ways of finding this. The shortcut way that we actually learned is to realize that arc length is the same as your radians times the radius. So if I knew how many radians 60 degrees is, I could just put that here and times it by the radius. I actually do know this one pretty easily. 60 degrees is the same as pi over 3. So I'm going to use a shortcut and just do pi over 3 and then times by the radius of 5. So the answer here is 5 pi over 3 in terms of feet. Now, I don't really understand what that means because of the pi symbol, so I'm going to do 5 times 3.14 divided by 3 and get a more realistic answer. When you do, you're going to get that it's about 5.24 feet is that arc length. Now, the second way you could have done this is you could have used the geometry method, which would just say take 2 pi r, which is our 5, and then you would take a portion of the circle. So you would take 60 of the 360 degrees. If you do that and simplify, you will get the exact same answer. 4.2a and b are together. We're going to understand what cosine, sine, and tangent represent on a unit circle, and then compute tangent given sine and cosine. So what we have here is a unit circle. It says they're going to rotate the point 1, 0, which is right here, that radius. And when they do, they rotate it and land it at the ordered pair TU. So what they did is they moved this theta movement and landed at TU. And they want us to answer these 2 questions here to the nearest thousand. Now this is the sine of theta, by the way. So they want to know if you move theta, or this angle movement, what is the sine? Well, we know that the sine means what is the y value. Well, the y value here is the letter u, but there is a numerical answer to that. This ordered pair right here, be careful. If you take it, what's going to happen is this point here would actually flip over here, and instead of being a right and an up movement, it'd be a left and an up movement. Well, this ordered pair here is just a reflection over the x, which lands you here. So technically what this is, the ordered pair TU, this was right and up, this is left and down. So I actually know that the ordered pair here is negative 0.940 and negative 0.342. So based on that, I can answer that the sine value is the y, so it's negative 0.342. Now tangent by definition is slope, and they want tangent of theta. The theta movement again is right here. So the slope of that angle movement, if you look at it, it's moving uphill. So one thing I know, the answer needs to be positive. But if tangent or slope, what it means is rise over run, or y over x, or in this case, sine of theta or cosine of theta. So all I need to do is take the sine value at that theta movement, and our angle movement is right here, so that's sine over cosine. If you just write that out, what you're going to have is negative 0.342 divided by negative 0.940, and when you simplify that, you get it's a positive 0.364. So the slope of this ray that creates that angle movement is this value here. 4.2c, we're going to find values of sine, cosine, or tangent with the unit circle using degrees or radians. This first one wants us to find the sine, or again, the y value of the movement 5 pi over 3. So we're just going to go to the exact unit circle and move 5 pi over 3. 5 pi over 3 is the same as 1 2/3 of a pi. So if you move 1 pi and then 2/3 a pi, you're going to land right here. And then notice on the exact unit circle, that ordered pair is at 1/2 and then negative the square root of 3 over 2. Here you need to recognize that the sine value is the y movement, so the answer for this problem is just negative square root of 3 over 2. Now the next problem wants you to find the tangent, but this time move 4 pi over 3. Well, 4 pi over 3 is 1 1/3 of a pi. So if we go ahead and move that, what we're going to do is move 1 of a pi and then 1/3 of a pi. So we land roughly right here. Here you're going to notice the ordered pair is at -1/2 and negative square root of 3 over 2. So now what you're going to do is find the tangent. Definition of tangent is sine over cosine. So remember the sine is the y value. All we need to do is to go to the ordered pair. Remember sine is y, cosine is x. So I'm going to put the negative square root of 3 over 2 divided by -1/2. So if we do that, we'll have negative square root of 3 over 2, -1/2. Now we have a complex fraction, so what I need to do is to get rid of the fraction in the bottom, so multiply by its reciprocal. And when you do that, the bottom here is going to clear out, so that all goes away. On the top half, the 2's cross out, and when you multiply straight across, you're going to have negative square root of 3 over -1. The negatives cancel, and we get that the tangent is the square root of 3. And it makes sense that it's a positive because it's an upward slope in quadrant 3. 4.2d, approximate the values of sine, cosine, or tangent with the calculator using degree or radian mode. They want us to approximate the sine of 6 pi over 5 to the nearest hundredth. Now if you look at the exact unit circle, we don't do anything over 5s, so we don't know it. So all you have to do for this is go to the calculator, you're going to hit the sine button, and you're going to type in exactly what you see here. But be very careful. When you type this in, it is the sine of, in parentheses, 6 pi, and then divide that by 5. You also need to make sure you're in the right mode. These are radians, so check the mode on your calculator and change it before you hit that button. When you do that, you will get that the answer is negative 0.588. Now I'm just going to have us double check that. If I were to do a quick sketch of 6 pi over 5, that's 1 1/5 of a pi. So just think about it logically. If you moved 1 1/5 of a pi, that would be somewhere in this range. Are the sine values negative in this range? They are, because you have to go left and down, so I know sines are negative, so that does seem like a reasonable answer. 4.2e, state an interval notation where sine, cosine, and tangent are either positive and or negative. We have 3 different questions here. The first one here says, for what values of theta from 0 to 2 pi? So we're going to go from 0 to 2 pi on the unit circle. Where are sine and cosine both positive? Remember, sine is y, cosine is x. So in which quadrant does that happen? We are going to notice that on here, the cosine is a positive movement is this direction and sine is here. So it's in quadrant 1. Now you don't want to say quadrant 1, you want to say what interval that happens. So that happens where the theta value is between 0 pieces of pi and pi over 2. So you would say 0 pi to pi over 2. Now you want to think about if you should have equals to here or not. So are sine and cosine both positive? So at 0 pi, that's the ordered pair 1, 0. 1's considered positive, but 0 is considered neither positive nor negative, so I would not include the equals to. This is the ordered pair 0, 1, so it's the same thing. So just keep the less than symbols. The next question wants to know for what values of theta from 0 to 2 pi are sine and cosine both negative. So that means x and y are both negative, so you'd have to go left and down. That's in quadrant 3, so that's going to be between pi and 3 pi over 2. So we'll just do pi as the smaller end, and then 3 pi over 2 over here. Again, I'm not going to put equals to here because these ordered pairs include a -1 and a 0, and 0 is not considered positive or negative. The last one, for what values of theta from 0 to 2 pi are cosine and tangent both positive? Well, cosines are positive on the right-hand side. Tangents are positive where the slope is positive, and that's going to be up in here. So it's going to be between 0 and pi over 2. So it's going to be the same answer that we had here, and I would just say between 0 pi and between pi over 2. 4.3a, find the exact value of sine, cosine, or tangent using Pythagorean's identity. So here it says, give an exact value of the tangent. So they want us to find tan, so I'm just going to make note really quick over here what tangent is on the side. Tangent is sine over cosine. So that's what we need to find ultimately, is sine and cosine, and put it in here and simplify. Well, they are giving us half of it. They're saying if the sine of theta is negative 3/5. Let's go ahead and put that in there right now. So sine is negative 3/5. What we don't know is the cosine. The key part here, though, is they're also telling us they're looking at the angle between pi and 3 pi over 2. So they're somewhere looking at an angle over in quadrant 3. Now, what we know about the angle movement, I'm not sure exactly where I land, and that's fine, but I know when we land right here, that ordered pair, I know the sine value. So I'm going to jot down that this is negative 3/5, and I don't know the x movement. So to actually answer the question of tangent, again, I'm halfway there. What I need to find is the cosine. When you're given an ordered pair and you know sine and you define cosine, you can use Pythagorean's identity. So let's use Pythagorean's identity to find cosine, plug it in here, and then we'll simplify our answer. So to do that, remember that we're going to do cosine squared theta plus sine squared theta equals 1. I don't know cosine, so I'm going to keep that there. But I know sine is negative 3/5. I'm going to square it, equals 1. Cosine squared, this is going to become 9 over 25. Now what I would do is subtract 9/25 from both sides, so let's just go ahead and write that over here. Cosine squared theta equals 1 minus 9 over 25. Now I may make the 1 a fraction, and when I do that though, I want to get a common denominator, so that'd be a 25, and that'd be a 25. So then I'm going to come on in, and I'm going to take 25 minus 9, which is going to give me 16. So cosine squared theta equals 16 over 25. I have to finish up the problem by coming in and taking the square root. When you do that, you can break it up, and you can write it as a square root of 16 over the square root of 25, which is 4/5. Now, be careful on this question, though. This cosine value, remember, I'm in quadrant 3. All cosines in quadrant 3 are negative, so I need to make sure to come in here and make this a negative answer. Now I can take this value and put it right here and simplify. So this will be negative 4/5. Again, I have a complex fraction here and here. I'm going to get rid of this by multiplying by its reciprocal. 5 over negative 4, 5 over negative 4. When we do that, these cancel, the 5's cancel, and we're left with negative 3 over negative 4, which actually simplifies to the fraction of 3/4, and that's the answer. Now, if I wanted to do the second shorter method with this like they do in pre-calculus, what I could do is realize I'm in quadrant 3 based on this statement. I'm going to show the angle movement of quadrant 3. This right here is my theta. What I know about theta, the sine of it is negative 3 over 5. So remember, sine is opposite over hypotenuse. I'm going to put the negative 3 here, and I'm going to put the 5 here on the hypotenuse. So then what I could do is use Pythagorean's theorem. If you do Pythagorean's theorem on this particular problem, what you're going to get is you're going to get negative 3 squared plus x squared equals 5 squared. When you solve that, you're going to get that it's 4. But then you're going to have to realize you can't just put 4 here because this is not a positive movement, it's a negative movement. So now you have your triangle. Then what you can do is go ahead and answer the question, what is tangent? Tangent is opposite over adjacent. So if you do that, you would get negative 3 over negative 4, which is this right here, which would simplify to 3/4. So either of these two methods work, just be careful with both of them. 4.3b, c, and d are find values of sine, cosine, or tangent by sketching and either using the opposites, the half turn, or the complementary and supplementary angle theorems. So I want us to look at this scenario here and answer some questions. Consider the unit circle again with the radius of 1, 0, which we have right here. They move and they land at the ordered pair TU. Keep in mind we've already done this. Remember, we realized this ordered pair here flips there, which flips there. So this is a right up movement, so this is left down. So I'm going to write that I know this ordered pair is a negative 0.940 and a negative 0.342. That's where the theta lands us. Now the first question is here. We've moved theta, so that's our theta movement. They want to know if you do the sine of the negative of the angle. Well, if this is the angle movement originally, it means the other opposite of that angle would be going backwards. If you move opposite, you're going to go backwards that same amount, and you're going to land somewhere about right here, would be that movement. When you do that, what is this ordered pair? This is just a reflection of that up there. This is a right, or a left and an up movement. So the left movement on that is going to be negative 0.40, and the up movement is a positive 0.342. Question is, what is the sine value? The sine is the y, so it's right there. The answer here is going to be a positive 0.342. The next one is the tangent of take your angle and add a piece of pi to it. So remember, our red angle is right here. If we add a piece of pi to that, that's 180 degrees. So if I take this and add a piece of pi, I'm actually going to do this, add on 180, and I land right here. So I actually land at this point right there. The question is, what's the tangent? Remember, tangent is sine over cosine. So we'll take sine over cosine. And in this case, we're going to take this value over this, so it's going to be 0.342 divided by the positive 0.940. When you simplify that, you're going to get a positive 0.364 is the tangent. Now this one here, they want the cosine of take the angle of movement, which is in the red, and subtract from it a piece of pi, or 180 degrees. So let me just show you, if you move the full red movement, but you have to back out a half of a circle. If you back out half of a circle, you're going to go backwards this way, and you're going to land right here. So we've landed in the exact same spot. The question is, what is the cosine? The cosine is the x value, so the answer here is 0.940. True or false on this one, and justify your answer. For all thetas or all angles, the sine of an angle is equal to the cosine of an angle plus pi over 2. I'm just going to go ahead and sketch an example for this. So let's do this first. Let's just plot an angle movement. I'm going to have this right here be my angle movement, and I'm actually going to use 60 degrees. And they're looking at the sine value. So look at your exact unit circle. The sine of 60 degrees is right here. It is the square root of 3 over 2. So this value is the square root of 3 over 2. Now the question is, will it equal the cosine if I take that particular angle and add a half of a pi to it? Well, if you want, keep in mind I use degrees here. They're doing a half of a pi. Well, I know that. That's just 90 degrees. So what I'm going to do is take my 60 degrees here, add 90 degrees to it. If I do that, I'm going to land here at about 150. Go ahead and look at the ordered pair at 150 degrees. It's the negative square root of 3 over 2 and 1/2. Here they want to know is the cosine. The cosine value here is negative square root of 3 over 2. So do these two things equal? They do not, and the answer here is that it's false. So you can either use a numerical example to show it. The picture here is a really great example to confirm our answer. 4.4a, find exact values of sine, cosine, or tangent on the unit circle using degrees or radians. So let's find all three of those values. Let's first find it for 225 degrees. So we always start here. This is a positive 225 degrees, which lands me right here. If you look at the unit circle, the ordered pair here is negative square root of 2 over 2, negative square root of 2 over 2. So all you have to do is read the information. Remember, cosine comes first, which is x. Sine comes second, which is y. So cosine is negative square root of 2 over 2. The sine is negative square root of 2 over 2. Tangent by definition is sine over cosine. So do show the work. Take the sine value, which is this, divide it by the cosine, which is this. Those just simplify down to being the number 1. The next one, move negative 5 pi over 3. So be careful. You might want to make this a mixed number. So for the mixed fraction, it's going to be negative 1 2/3 of a pi. Careful, we have to go backwards. So on the circle, negative 1 pi is right there. If you partition off again the circle into thirds, you're now going to move 2/3 of that backwards, which means you're going to land about right here. If you do that, where we've actually landed on this unit circle is at the value of pi over 3, the positive one. The ordered pair here is 1/2, and then the square root of 3 over 2. Again, we can just go ahead and answer the question. That's cosine and that's sine, so that's pretty easy to get cosine. The sine value is square root of 3 over 2. Tangent is sine over cosine, so for this one I'm going to take the sine value over the cosine. I do have to simplify this complex fraction by multiplying by its reciprocal. And when we do that, pretty much everything just cancels out in here, and we're left with the value of the square root of 3. 4.5a, they want us to use sine and cosine to evaluate functions. There's a couple ways we can do this. So here they say from 0 to 2 pi, state all the values that are true when the sine of an angle is equal to 1/2. If it helps you, I would just go to the actual unit circle and find the various ordered pairs on here where the sine is 1/2. You're going to find that one of them is here at 30 degrees. You're also going to find that another one here is going to happen at 150 degrees. Now be careful, they want between 0 and 2 pi. So we have to look and see at the circle how many pieces of pi is that. So the answer for that one, it's going to happen at the values of pi over 6 and 5 pi over 6. Now a second way to actually do this problem is just to solve it doing the algebra. To get the x by itself, all you need to do here is the inverse sine. So what I would type in the calculator is the sine negative 1 of 1/2. I would be careful, make sure I'm in radian mode. When you do that, what you're going to get is you'll get that it's 0.524 is the same answer as pi over 6, but pi over 6 is just exact. So the only thing you can't get from this calculator is it only gives you the one answer. There actually is a second answer that meets the same requirement. This one here wants you to solve for x, so it's going to be really similar to the second method here. To get this x by itself, it's just basic algebra. I need to move the 2 and the plus 1. First thing I want to do is move the plus 1, so I'm going to subtract 1 from both sides. You're going to get 2 cosine of x equals negative 1. Now divide by 2. So the cosine of x equals negative 1/2. You can sketch the circle if you want to for this one and determine the location of where cosine of x equals negative 1. The negatives would have to be over here somewhere. So when you look at that, you're going to see one of them happens right here at 2 pi over 3, or 2/3 of a pi. The other one is going to be down here, and that's actually going to happen at 4/3 of a pi, or 4 pi over 3. Now what you can do is type in, again, the calculator, do cosine negative 1 of the number negative 1/2. When you do that, you're going to get, the answer is 2.09. And that's going to be equivalent to the 2 pi divided by 3 if you were to put that in your calculator. 4.5b wants you to sketch 2 cycles of sine and cosine parents function. But instead of doing that, we're just going to answer a question related to the parent. Below is part of the graph of either sine or cosine. They want to know which it represents. Is this sine or is this cosine? So what you first want to notice is where the x-intercepts are happening. Here the x-intercepts look like they're happening at all the integer values of pi. So what you don't want to do is take this and go back like you started at 0. That's not the point. If you sketch sine and cosine really quickly, here's what they look like. Remember, the sine looks like an S shape from 0 to 2 pi. The cosine looks like a C shape from 0 to 2 pi. Notice the x-intercepts on here. The x-intercepts for the sine function happen at 1 pi and 2 pi. For cosine, they're at odd multiples of pi over 2. This graph's, again, x-intercepts happen at integer values, so therefore this has to be the sine function, and it's because the x-intercepts happen at integer values of pi. You would want to write something along those lines. 4.5c, determine domain, range, minima, maxima, zeros, amplitude, and period of sine or cosine. What I've given you here is a particular sine graph, it says, and I just want you to state those various elements for this particular graph. Keep in mind this is not the parent function. This graph has been shifted. The domain of that, or the x value, there is no break in this graph, so the domain is all reals. The range for this graph is how high can it go. The range on this graph can go up to 2. The minimum value on this graph, it goes as low as right here. The lowest value it can go is at 0. The maximum value is 2. So the minimum is 0, max is 2. Where do the zeros happen? Well, that just means the x-intercepts. If you look at this, where I see the x-intercepts happening, we're at 3 pi and we're at negative 1 pi. The amplitude for this graph is how high is the hump. Now be careful, they would say take the distance, so 2 to 0, and divide it by 2. So the distance is 2, but if you cut that in half, the amplitude here is 1. Another way to see that is just imagine, the sine function. If it were through the x-axis, you would see an equal hump here and an equal hump here. Each hump is 1 unit high. The period is how long till it repeats its pattern. Well, here's its pattern, and then it starts to repeat. The length of that is 4 pi units long. 4.6a was not going to be on the test for sketching the tangent function. 4.6b, though, determine domain, range, and asymptotes in zeros and period of tangent. Let's just focus on the asymptotes of the tangent function. From 0 to 2 pi, state where the asymptotes are on the tangent graph. The key thing to remember is this tangent graph that we're going to draw comes through the unit circle. Tangent just means the slope of the line. So on the unit circle here, where is the slope undefined? It's undefined at vertical movements. So when we see this put onto graph paper, and if this is pi and that's 2 pi, when we hit pi over 2 and when we hit 3 pi over 2, what we're going to see are some asymptotes are going to be drawn because this is unable to actually plot a slope. So the answer for this is, where are the asymptotes? They're going to be at pi over 2 and at 3 pi over 2. Explain why they exist. Because the slope is undefined. And if we finish graphing just what tangent look like, just so you get an idea, this right here is what tangent look like when you move from 0 to 2 pi. 4.6c wants us to use the periodicity theorem and find exact values for these. So we are going to use the exact unit circle, but the problem is these 3 values never show up on the exact unit circle. So remember, let's just do the movement and see where we end up landing. First thing I would do is make this a mixed number. So this is really going to be, what is the cosine of 2 goes evenly into 31 15 times, worth the remainder of that. So what I need to do is go to the unit circle, and I'm just going to move 15 1/2 of a pi. So let's move 15 pi's. So this is going to be 2 pi, 4, 6, 8, 10, 12, 14. Now I'm going to go a 15 pi, and then I have to go half of a pi. A half of a pi lands me right here. So I actually landed at 270 degrees, or I landed at 3 pi over 2. This is the ordered pair of 0, -1. The question is, what's cosine? It's right there. The answer here is going to be 0. Now, on that one, you realize we had to go around this circle a complete 7 rotations before we could start to do the red portion of the graph. Let's do this one. They want the sine or the y value. They want us to move negative 765 degrees. Well, what I'm going to do is actually see how many complete circles I can pull out of that. 2 circles at 360 degrees is 720. So what I know is this is 2 complete circles with a remainder of 45 degrees. That'll give me the total. But be careful, I have to go backwards. So let's sketch this. I'm going to go a negative 360, another one which is a negative 720, and then I have to move negative 45 degrees. So I actually land right here. And what that is that's actually at 315 degrees. This ordered pair is going to be square root of 2 over 2, negative square root of 2 over 2. They want to know the sine value, which is right here. So the answer is negative square root of 2 over 2. So on this one, I had to go around the circle backwards 2 complete times before I could move that last 45 degrees. Here they want to know the tangent of 1,920 degrees. Again, I'm going to see how many circle rotations that is, and I can't see it really clearly in my head, so what I'm going to do is take 1,920 and I'm going to divide it by 360. When I do that, I get 5.33. So I'm going to pull out 5 circles from here. So 360 times 5 is 1,800 degrees, which means I'm left with another 120 degree movement. So what I'm going to do is go to the circle, and it's a positive movement. So I go around the circle once, 2, 3, 4, 5, and then I'm going to wrap up and move 120 degrees, which is going to land me about right here. This right here is the ordered pair. Negative 1/2 square root of 3 over 2. Now they want to know the tangent, so I'm going to do sine over cosine. So I do square root of 3 over 2 divided by negative 1/2. I'm going to therefore multiply by the reciprocal, and this is going to simplify to negative square root of 3 is my final answer.